So we have Darcy and Ryan with us today. Darcy Jones, who is ITEA's STEM CTL Director of Innovation, is a graduate of the Technology Education Program at Millersville University of Pennsylvania, where she was introduced to ITEA and TICA, and we had a TICA seminar recently as well. And as a result of those two associations, became a proponent of STEM education. Darcy spent the last 4 years as a lab technology teacher in the Northern Virginia area and 1 year as a school test coordinator. She recently attended the George Washington University College of Professional Studies program to continue her education in the area of STEM and received a programming and coding certificate. So we also have Brian Nowitzki with us today, who is ITA's STEM CTL Director of Learning. He is a graduate of Oswego University in Technology Education, McDaniel University in Educational Leadership, and is currently pursuing his doctorate at the University of Maryland Eastern Shore. Brian has served as the K-12 level at the K-12 level as both a technology and engineering educator, along with a vice principal. Mr. Nowitzki has been an active ITA advocate, including presenting at ITA conferences as a national teacher effectiveness coach, and as part of curriculum writing committees for ITA, as well as for AP College Board. So without further ado, Brian and Darcy, take it away.
Thank you, Rebecca. All right, well, thank you for joining us to celebrate Engineers Week with Discover Ease and designing the future through engineering by design. And directly linked in there is the presentation. There are also several QR codes and links embedded within this presentation. So today we will begin with an overview of ITEA's standards for technological and engineering literacy, the 6E learning model and engineering by design, and then transition to the design briefs available in the Technology and Engineering Teacher Journal, and conclude with website navigation and access to ITA's site, Discover E, and additional resources. So there are QR codes embedded within the presentation. They will take you to areas within the webpage. There are also several folders with resources, presentations, and we're going to start by looking at an overview for the STEL. So there should be sound. This is linked in there if you'd like to view it on your own time. I'm not sure if the screen sharing did not allow for the audio, but this is a 2.5-minute video. It's great. And it is linked in there too. So you can always go back and view this on your own time, and it's on YouTube.
One sec, I'm going to reshare my screen. Here we go.
I apologize for screen sharing. issues. Yes, I apologize about the sound issues. It is directly linked in there if you would like to go back and view it on your own time, but I do apologize. So the 6E model, the basic premise of the 6E learning by design model was developed as a student-centered model that would blend design with context and concepts and inquiry. So having used the CS5E model for many years, there was always the struggle that design was not fully represented. And so to that end, this new model adds an E called engineer. And so in this phase or cycle is where students truly design and model as engineers would. The 6E model engages students through experience, questions. Students will explore through predictions, experiments, observations. They will explain through developing, processing, and growth through the engineer, lowercase e, by applying, conceptualizing, modeling, and creating. And learners will be enriched through interactions, questions, experiments, hypothesis, and evaluation through analysis, synthesis, and revisiting. And embedded in here, there are some sample design challenges you can try out with your class. So ITA's mission is to advance technological and engineering capabilities for all people and to nurture and promote the professionalism of those engaged in those pursuits. So ITEEA seeks to meet the professional needs and interests of members, as well as to improve public understanding of technology, innovation, and design and engineering education and its contributions. Discover E works to ensure people everywhere understand how engineers, technicians, and technologists make the world a better place. So 30 years ago, they were the first to call on the engineering community to volunteer and in their local schools and community to help young students discover engineering. Now they lead a growing volunteer and educator movement recognized worldwide. So this week, we are helping to celebrate their legacy and build for the future through engineering by design. We're now going to take an example design brief from the engineering by design curriculum, starting with elementary grades. The STEM Center for Teaching and Learning encourages teachers to adjust their lessons and curriculum to best fit their students. So these can be tailored to your students' needs or the materials that you have readily available, or even your classroom environment. So in engineering by design teams, Next Gen Grade 2, this engages young learners in hands-on inquiry and design as they explore biomimicry, one of the most important challenges of the 21st century, and how learners can obtain from nature the tools necessary for scientific discovery. So the building block integrates concepts of science, technology, engineering, and mathematics through the environmental context of learning about bees and researching why they seem to be disappearing. By utilizing an experimental approach, students can collaboratively begin to explore how animals spread seeds and how their environment is suitable for habitation. So this design challenge has students work in teams to brainstorm and design a device that would travel to disperse seeds. Students are also tasked with documenting their knowledge and design process using STEM notebooks and their design journals. The time frame is listed, but can be adjusted to best fit your schedule depending if teaching in a hybrid environment or if you're wanting to co-teach this design challenge with a teacher from another curricular area. Materials are also listed on the next slide and can be modified or additional materials added in. And the next design challenge is intended for grade 5. Nctm's Next-Gen Grade 5, Our Water, Our World, engages learners in hands-on inquiry and design as they explore one of the greatest challenges of the 21st century, and that is universal access to clean water. So this building block integrates the concepts of science, technology, engineering, and mathematics through the environmental context of water resource management and conservation. So by utilizing an experimental approach, students collaboratively investigate global water issues and learn that stewardship and innovation can make a difference in the world's problems. Apologize. So in these design challenges, you will see the course objectives, the context, the challenge criteria, as well as an estimated time frame and how you would evaluate them. These are not formal lesson plans, but are intended for you as a sample to see the engineering by design curriculum and as a design resource and challenge for your class. So we encourage you to use these and try them out with your students. And directly linked into every title here in the design challenge are added glances for the engineering by design curriculum. And from there, you can see objectives and what the course content. It's really an overview of all of the curriculum offered.
Hi, good evening. Now we're going to go on to discussing the middle school design brief as well as the high school design brief. And welcome to our engagement of the Discovering Engineering Week. Inventions and Innovations, which has been currently revised for this school year, has a design challenge that's embedded directly in it, and it's completely around upcycling, or specifically upcycling waste. What's very unique about this design brief overall is we're not trying to get students, for instance, to go through and just use shopping bags to go through and recycle. We're really trying to get the notion across that everything in life can be upcycled in order to conserve the greater good. So we're trying to preserve our environments. We're trying to learn how to go through and clean up areas, and then afterwards take it and repurpose it for something bigger and larger. As mentioned before, everything is linked within the blue hyperlinks. So the individual design brief, when you left click on Inventions and Innovations, brings you directly into the design brief. It gives you a one-pager on how to use this for your students overall. The time frame for this is approximately 2 to 3 hours. The students truly and authentically love this type of challenge. And the context of it overall is to grow as the population is just continuously growing over and over and over. We're trying to find the need to make something better and clean up and use it for the greater good. So really taking things that people sometimes consider trash and putting it into usable items. For instance, it could be pallets found that the custodial staff may be throwing away. You may take that afterwards and then repurpose that and turn it into pallet furniture. You may find shopping bags afterwards, repurpose it and turn it into bracelets or necklaces, etc. You're really trying to take anything you can around you and to show the students the greater purpose and the greater cause, to take it, repurpose it, and intertwine it toward the great, bigger, larger purpose. Another example of this would be, for instance, all the cardboard that gets thrown away sometimes or put into the recycling. I know that throughout the year, as far as for COVID, whether it's Chromebooks that are being distributed or it's iPads, etc., there's a lot of boxes. And sometimes we can repurpose those. For instance, you may do something where the kids go through and design cardboard furniture. So they are able to see this bigger picture and able to use it for a different purpose. Here's some examples of it via photos that were done in a classroom as well too. And as you see the students in the bottom right picture, they're wearing their bracelets, they're showing them off, they have their bling, and it's a really nice idea for the students to really understand the greater purpose. And the students, they don't just wear them for a day. Sometimes they come 2-3 weeks and later on, they're still wearing those bracelets. So the challenge itself is for students to use the engineering design process to identify a way to upcycle unwanted plastics bags into a usable product. But if you don't always have, like I mentioned before, plastic bags, you can use pretty much anything that you find can be repurposed or recycled for a greater purpose and cause. Another example of this I've done specifically within my classrooms is we've taken all the cardboard that was thrown out when our new school opened up, and then we took them and turned them into Frank Geary's cardboard chairs afterwards, the wiggle chairs. And the kids just simply loved it. Not just because they get to go hands-on and use materials, it's because they really start to see the bigger picture and bigger cause. They then get evaluated overall in the documentation of the design process in their engineering journals, and they're able to show this, talk about the problems, identify solutions, and brainstorms and work collectively together on an upcycling waste design challenge. At the high school level, a newly revised course, Technological Design, has a digital tape measure challenge, which is approximately a 6 to 8 hours challenge. And this is all around electronics and robotics. This course focuses a large portion on hands-on integration of electronics, but also the digital version as well too via online, via Tinkercad Arduinos. So this course overall brings together two different aspects where you're able to use the Arduinos physically in front of you or do it virtually as well too. When you left click on technological design, it'll bring you to the design brief overall, and this will help students to acquire a knowledge of electrical components, circuits, and the creativity to apply these continually changing components in unique and creative ways. This is a very unique design challenge via the design brief because it gives you autonomy for the students, like I mentioned before, for the physical or the virtual learning aspect of it. This is actually labeled as one of our preliminary challenges named Digital Tape Measure, in which students research the electronic components to utilize in solving a technological problem of creating a completely digital tape measure. Students will integrate knowledge gained in prior learning cycles with research while being creative in design and coding. They'll demonstrate a wide variety of planning, design, construction, and coding skills to be successful in this challenge. This challenge can be taught using hands-on, as mentioned before, physical components, or simulated using Tinkercad circuits. This is a very fun, great, engaging challenge for virtual learning overall. In each of our design briefs, it is always strongly encouraged for students to use their engineering design journals to document that process overall. So they get accreditation for the work they're doing from start to finish with the design problem, defining the problem, to the end of the 12th step at the end of the day to communicate that result. Because they don't communicate the results to reflect on it and to innovate in the future, it's very difficult to understand the greater scope of a design challenge overall. The materials for this can be utilized on Tinkercad circuits as well as a Arduino kit. A 3D printer can also be built to enclose for particular devices. And afterwards, they'll have availability and use of materials for while depending on the availability of tools and materials. They may not always have the tools and materials, and that's perfectly fine. That's why we offer the virtual sense of it as well as the physical. Engineering by Design is a pre-K-12 curricula in which we offer content pre-K to 12. In order to get access into our Engineering by Design content overall, what you can do is if you're navigating on the PowerPoints, I can left click on there, and it'll bring me directly into the ITEA.org website. And when I left click on Global STEM, which you would do
your screen, actually, I apologize. I'm not sure if they sent out an update. Things seem to be a little different with the screen sharing.
Apologize for that. So when you're in the PowerPoint and you left click on the ITEA.org icon, you would go directly into the website, ITEA.org. You would then left click on Global STEM. When you left click on Global STEM, you would left click on STEM by state. And then when you left click on STEM by state, you would navigate to your applicable state overall. Let's just say for Virginia. And then in regards to getting access to course content, resources, etc., you would left click on accessing EBD curriculum. And there's specific instructions that are specific to your state. Sometimes you go through and you fill out the negotiated agreement and you'll send it to me or to your EBD state director, which is listed on your contacts for your state overall. You can also ask for request of the EBD coursework in order to get preview access of it. The STEM CTL is a component, or it has 4 different areas that we focus on. We focus on curriculum, assessment, professional development, and we focus on research. Within those 4 areas, that we focus on for the STEM CTL. We are constantly using research to make informed decisions on how to change our content or how to offer further professional development and learnings to best suit the teachers and students of the 21st century world. We have, as mentioned before, our 6E learning by design model via our lesson plans that are implemented within our course content. We use assessments that are embedded within our learning management system, or acronym LMS, our Buzz portal, in which you can use data analytics to gather Excel spreadsheets and how to diagnose your students from the beginning of your course to your end of your course to see as far as overall growth. A lot of the times what I see teachers and educators doing within districts and individual schools, they use that data to help to go towards student learning objectives or overall evaluations or measuring student success. So that way the teacher can reflect on that for the next year, the forthcoming year, to recraft or rehone their practices for the following school year. We are standards based with the Standards for Technological and Engineering Literacy, Next Generation Science Standards, National Engineering Grand Challenges, Common Core State Standards, and they're all aligned within our content and curriculum overall. The STEM CTL, acronym CTL stands for Center for Teaching and Learning, was established in 1998 to strengthen professional development and advanced technological literacy. Center initiatives are directed towards 4 goals: development of standards-based curricula, teacher enhancement, research concerning teaching and learning, and curriculum implementation and diffusion. I want to take a moment to focus on why I'm talking about the STEM CTL initiatives during Engineering Week. We offer a lot of different opportunities for educators, especially in the professional learning world or professional development. A lot of our professional development is delivered virtually. We also do a lot physically as well too. With COVID, we've changed a little bit of our direction. We offer courses though, such as microbadging. Microbadging are courses that are delivered through Google Classrooms, and there's offered professional learning hours that are built in with it. There's 10 different courses for each focus area. One of the focus areas is around microbadging for safety. So all the new upcoming ideas for safety, what's going on, but it talks about the traditional tools in classrooms, not just traditional tools in classrooms, best practices around chemicals, 3D printers, emissions from 3D printers, how to go through and do best practices in regards to safety overall in a lab, etc. It also talks about enhancing practices in the classroom. And there's also a collaborative sense. So the people that are in the classroom with you, as far as the educators, the professionals, there is a collaborative sense environment put into there so you can discuss things amidst one another, as well as the person overseeing the classes. Our other focused area for this year is digital literacy. In the presentation, if you left click on that, it'll go directly into the registration region. And for digital literacy, we focus on a lot of different spots within there. For instance, one of them is directly around differentiation of technology integration in the classroom. So there's several different instructional technology strategies that you can use within the classroom, but then afterwards, there's also the autonomy to learn about a assessment tool to see whether or not is a technology integration effective. And there's models to measure the effectiveness of technology in that classroom. So that's one of the several areas within digital literacy we focus on, as well as for safety, those are the individual series we offer through the STEM CTL. The STEM CTL also offers a 3-day institute, which is to help educators or professionals become authorized teacher effectiveness coaches. And essentially the state that you reside in, once you go to this training and complete an internship, you are then authorized to deliver workshops within your state. So for instance, if you teach in the state of New York and you attend one of our ATIs, you would specialize in one particular course. Let's say, for instance, you went to go sign up for technological design. You would then work with one of our national coaches over the course of a weekend and learn the content inside and out in full tilt what ITEA and EBD is all about. From that standpoint, You would do an internship with a national teacher effectiveness coach. And once you do that internship, you can then lead workshops within your state. So if a New York State representative of education that is requiring you to, or requiring somebody to do a training on technological design, you can then be sought out afterwards and then lead a workshop on there. The next thing is also, if you want to take more than one course over the course of the weekend, you can only do one course the weekend, but what happens afterwards, say I want to get trained in FOT, I want to get trained in computer science principles by design. You can definitely do that as well too. The coach works with you afterwards to get together on specified dates with you on a Saturday or Sunday, conducive based upon your schedule and needs, to go through and learn about that course so then you can be actually trained up to 3 courses overall. If your state is a consortium state, the virtual ATI cost for it is $1,000 to train in one course. So that's a fee that's actually for consortium states. That's a reduced cost. We also have a reduced cost even for non-consortium states from the traditional ATI where it was last year. These are all delivered via virtual means through Zoom platforms. So an agenda, a coach we assign to you, agendas will be sent to you, emails for updates. And similarly, as we're going back and forth now, but there's a lot of dialogue that happens in the virtual ATI. So we're able to converse with one another, talk to one another in a completely open environment between all partisans. There's some further at-home resources with Discover E and ITEA overall. That's hyperlinked directly within our presentation. And there's teacher tips for distance learning, creating a STEM-friendly home, why the engineering design process, or why it matters now more than ever, that are embedded within there. And that's located directly when you left click on that link in there, it goes to our page right here. And it says, as we all navigate the new realities of learning and teaching at home, Discovery has created a new resource, At-Home Engineering. So you'll see a lot of resources in here that are just, it's a collaborative environment. It's great to share it out. And I'll left click on this photo right here, which brings you into a Discover E challenge that's called Slow It Down. There's instructions via documents for this one. They talk about the grade bands that it could be utilized for, such as 3.5, 6.8, 9.12. And it also mentions the discipline overall, which for this instance is aerospace. The grades or disciplines for another one for a step launcher, mechanical, civil, industrial manufacturing, agriculture and biological, chemical, civil. And as we go through this, you see a lot of different STEM disciplines that are portrayed directly on this site. So science, technology, engineering, mathematics, material sciences, industry. So whichever courses you go through and you pursue and you teach in your classrooms, or if you want to integrate different disciplines in your classroom, it's definitely a good resource to use overall when considering different integration of STEM disciplines within your classroom, especially the iSTEM environment. I want to make sure that I have my sound turned on. Also going to left click on this video right here to show one of the videos.
Hi all! Today's Discover E challenge is a chilly one. Your challenge is to create a container to keep an ice cube from melting. So this is where we need to start thinking like an engineer. And to do that, we first must identify the problem. The most critical step of any engineering challenge is to understand the problem you are trying to solve. The problem we are trying to solve is heat transfer. Heat transfer is the movement of thermal energy from one thing to another of a different temperature. The laws of physics tell us that heat tends to distribute itself evenly. Understanding the principle of heat transfer helps engineers design things like thermoses, roofing shingles, materials to keep spacecraft from burning up, and many other things. For this challenge, this is when the heat in the air of the room is transferred to the ice cube, causing it to melt. Insulation is any material that reduces heat transfer. For this challenge, we need to think of ways to use insulation. Think about our homes. Insulation is used in the walls of our homes. This helps keep the inside of our homes warm in the winter and cool in the summer. Insulation in containers can help to keep things hot or cold. Again, think back to the thermos. Now it's time to collect the materials for our challenge. You can use anything you'd like, but here are some suggestions of what you might want to use. A cardboard box of some kind, tape, paper or wax paper, aluminum foil, rubber bands, plastic containers. Be creative. You could use old rags, shirts, towels, anything at all. Anything you think might work.
So one thing I also wanted to make sure to mention is our overall objectives for today. We really wanted to show you different ideas to do for Engineers Week. We showed some design briefs overall. The design briefs are given there as resources that you can utilize. Feel free to use them in your classrooms or to reach out to us at any time with any further questions, comments, or concerns. Those design briefs can also be interchangeable. They give you some resources and recommendations, but it's not required to use those materials or the recommendations based around the same premise that are aligned towards national standards. We also wanted to highlight some different initiatives to help you grow professionally within the STEM world, as well as show some additional resources via Discover E. I did want to conclude by showing our virtual conference website for more information on registering for the ITEA virtual conference. This is a phenomenal opportunity to start to learn different disciplines in STEM, technology and engineering overall, about the standards for technological and engineering literacy, as well as different coursework. I'm gonna share the screen real quick. And I'm gonna navigate to the ITEA website, Control C. And then go to the registration page. On the registration page for the ITEA virtual conference, March 22nd to 27th, there's a promo video for the virtual conference, as well as information on how to register. When you left click on register now, there's options to register as a member or a non-member. So if you're a member, there's a discounted rate for it. And our theme for this year is for where technology and engineering education come to life. The overall focus for the conference this year is on the way educators make technology and engineering education relevant for all. Educators use active learning, authentic assessments, collaboration, and put research into practice in order to help technology and engineering come to life. If you scroll down just a little bit over here, and then you left click on virtual conference at a glance, that virtual conference at a glance then helps to kind of put in perspective what is being hosted during the conference overall. For instance, if you left click on workshops, and when you left click on workshops, it'll give several different workshops that are held during the entire course of the week. For instance, we have Advanced Technological Applications, Soft Robotics as an Innovation in STEM Learning workshop that's being held from 3 to 3:50. As long as you're one of the first 40 participants that registers for the workshop, you can go through afterwards and a kit will be sent to you to develop your own prosthetic finger. A lot of fun, a lot of interactive, asynchronous, synchronous workshops that are hosted throughout the entire week. We hope to see you there, and thank you for attending our virtual presentation tonight for Engineers Week.
Thank you so much for joining us. I hope we were able to provide you with some resources where when things are uncertain that you're able to tailor them to your class or use as an icebreaker activity. But thank you for joining us in Engineers Week. And I'm going to post an additional link here in the chat. Some of the design briefs are linked into ITA's site, and it will also direct you within the STEL.
Thanks, Ryan and Darcy, for that awesome presentation. We're going to get started with our Q&A session. So if anyone has any questions about EBD or any of the design briefs that were shown tonight, please place your question in the Q&A box down below, and we will answer those questions in the order in which they are received. So our first question is, If I'm not a consortium state, how can I access EBD curriculum, or can I access curriculum?
That's a great question. If you are not a consortium state, I'll go through and share my screen again. If you're not a consortium state, you would still go to the ITEA webpage. And on the ITEA webpage, you would still do the standard procedure where you left click on global STEM, STEM by state. And if I chose a non-consortium state such as Texas, what I would do is I would still do the same process. I would left click on accessing EBD curriculum. I would scroll down, and there is a non-consortium network agreement form that is right here via PDF. And once you fill that out, you follow the applicable areas, spots to fill it out for. I want to choose FOT, INI, technological systems, pre-K 6, whatever one you choose to do. Once you fill that out, you fill it out with the payment information, you send it over directly to me, and then we help to process you getting access into the content. And it's the same abilities to preview all of our courses via our learning management system. So if you left click on request for EBD course review access, you'll be able to get a preview form, which gives you a little glimpse, a snippet, snapshot, one lesson here, one lesson there in individual units. So that allows you to kind of get a feel of our coursework overall. We also have our standard edition, which is available and download for purchase at the ITEA store. The major difference, though, between, as I mentioned before, with our LMS, the learning management system works very similarly to any learning management system where it allows with data analytics. The standard edition does not come with that pre and post assessment overall. It's obviously not offering you the autonomy to do the data analytics for showing student growth as it is a PDF document.
Awesome, thanks for that, Ryan and Darcy. So the next question is, can these courses be used in a hybrid context? So a little bit of in-person, but also online and virtual at the same time.
Engineering by design is a concept that is built in a way that's equitable and usable by all. As mentioned before with the design brief for technological design, or even as mentioned before in the other courses for INI, as you see coursework, it is able to be amendable and changed and innovated to meet the best needs of your students in your classroom. As long as you're going toward the same overarching standards and objectives for your individual lessons, your students can achieve mastery in the course. With the design brief for tech design, we talked about the Arduinos. There's the physical version of the Arduinos that are embedded within the content overall, but there's also the virtual sense. So as you're working in that virtual space, you have the Tinkercad Arduinos to work with. So therefore, you can go through and get the same objective. You may not get the hands-on experience due to whether it's lack of resources or funding for the physical aspect, but they can still understand the same concepts toward the same overarching standards and objectives via the lesson. Even in the upcycling challenge, living in the virtual world or teaching in the virtual world in that virtual space, students can go through and then just access anything they can around them for that upcycling challenge overall, however they want to use that or best fit for it.
Awesome. So it sounds like it's equitable to be used for pretty much anyone in any circumstance.
Mm-hmm.
Are these design briefs full lesson plans?
Great question. The design briefs are not full-blown 6E lesson plans. The design briefs are a snapshot where it's just enough information to give the content as far as saying this is what the challenge overarching is, but it's not, for instance, to say this is your engagement, this is your exploration, this is your evaluation, etc. It's not going through that individual layer, but it's saying this is our challenge overall that you can feel free to utilize. And if you like the design challenge overall, you can contact us to kind of get more information on getting more design challenges or design briefs and content through Engineering by Design.
And are these courses connected to STEL?
So what you're gonna be seeing is all of our courses are in the process of being aligned to the standards for technological and engineering literacy. The newly revised courses are already aligned to the standards for technological and engineering literacy, and all the coursework is going to be aligned directly into the STELs by the 21-22 year. Right now, they're all aligned to the NGSS, the CCSS, Grand Challenges for Engineering, Engineering Habits of Mind, industry aspects, as well as the former STLs, which are being updated into the STELs for the coursework for 21-22.
Let's see. And how did those design themes get chosen? There's a wide variety of different themes and focuses. How do those get chosen? Do they change around often?
As we think about, for instance, innovation or change to, let's say, a cell phone, as it gets redesigned for a different purpose, faster Bluetooth, the faster battery power, connectivity, maybe they use different materials so it can actually be recycled. We revise and innovate our curriculums to make them student focused and future ready. So as the years, decades go by, we revise our content, our curriculum to make them most relevant for students to be successful in the 21st century world. So like for instance, the upcycling design challenge or design brief that we showed earlier, or the design briefs that we showed for the technological design course, we integrate and innovate our content to make them relevant for students to be successful in the 21st century world. As we know, there's a huge demand for students that need to understand iSTEM or integrative STEM disciplines. We take the comp side, put the hands-on approach to it too, with a technology and engineering education perspective on it overall, with integrating science principles and mathematics. So we see all those disciplines coming together, and we're innovating our content to meet the needs of the child for those next steps, post-secondary education. And our middle school content and our elementary content follows the same process. So we find what's most relevant for students and what's most applicable to being successful when they get to the high school and post-secondary education. So we build these courses as a ladder step along the way, so they're successful at the next levels. But they're constantly being revised to meet the needs and demands of the societal world as of right now and for the future.
So speaking of access to these design briefs and courses, you mentioned that to get into contact with your EBD state director. Does every state have an EBD director? And how can that process get started of bringing EBD to a state or a school district?
Well, in regards to a school district or a state, the first liaison would be myself or Darcy. Feel free to send us an email, and what I'll do is also I'll put my email in the chat to begin that conversation to help to spark your state to become an affiliate state or a consortium state overall. So that would be the first step. In regards to your individual school being affiliated as in regards to getting access to the content and resources of engineering by design, you can feel free, as I mentioned before, on the ITA navigation to go to your individual state. Even though you may not be listed as a quote consortium state, everybody has the autonomy to have access into our content from the states into China and past. So everybody has access to the content. It's just built directly in through the ITA website. And then if a state wants to become a consortium state, or if you're interested in becoming a consortium state, or even want more information as an individual school, please feel free to email me at any time. And I typically respond within the same day or the day thereafter.
Perfect. I'm going to take it to the chat. We have one comment and then one question. Someone had mentioned, actually it's from the same person. As a biology educator who used the 5 E's, I appreciate the connection with the E for engineering. Great idea. And you mentioned alignment with the next generation science standards or NGSS and others. I may have missed it, but is there an alignment with the Nctm standards?
So as it relates to the National Council of Teacher of Mathematics, if I'm not misspoken, in regards to that respect. So we are aligned to the CCSS standards, which talks for the algebraic, geometry, your trig, and pre-calc, physics, statistics. So we align directly into the NGSS and the CCSM. But as regards to the Nctm, we don't directly align directly in the Nctm. We align to the Common Core standards.
Thanks for that. So you mentioned real world examples. How about careers? Are there connections to careers in these?
Yeah, so we are aligned also into industry aspects. So there's 11 different industry areas that we focus on overall for our coursework. And what I'm going to do is I'm going to also pull up an example of that. 1 second, please, and into our Buzz system. And what I'll also do is I'll share my screen as I navigate into the Buzz portal. So we focus on all aspects of industry. When you go into log into your interface overall for the coursework, you would left click on the course overall, such as advanced technological applications and navigational standpoint. There's course descriptions, agreements, and organizations, additional resources for safety, EBD, and then you have all aspects of industry. So let me zoom in just a little bit more. As I zoom in a little bit more, we have our all aspects of industry that focus, and actually you can find out more information on workforce readiness right here on the www.ed.gov website, industry aspects such as business planning, and then we provide that alignment directly in the course such as agriculture, learning cycle 1, learning cycle 4, preliminary challenge. U1 stands for unit 1, LC stands for learning cycle, pre-C stands for preliminary challenge, PRIC stands for primary challenge, and these are the ones that are directly aligned to business planning industry aspect. There's management, health, safety, and environment, finance, community issues, principles of technology, personal work habits, labor, technical, and production skills. I think I said 11, but I'm at 9. I misspoke.
And while you have that up, you referenced the preliminary and primary challenges in there.
Mhm.
Can you talk about the two of those? What
course.
the differences between the two?
These little carrots, when you left click on them, they drop down and you can see them directly going towards other areas you can click on. So what's very unique about engineering by design is that we offer preliminary challenges, we offer primary challenges. So just as a standard multiple choice test is given to students at the beginning of a year, or rubrics, or however you go through and you assess your students, it's very similar to gathering a baseline data on the student's current understanding towards those overarching objectives and standards. So if your unit, for instance, Unit 1 and the Unit 1 overview, there's going to be standards and benchmarks on the next one over. So I'm going to go over here and navigate to the right. It lists your standards. It lists everything that's going towards in that overarching unit. So whether it's the NGSS, CCSS, etc., those are your overarching standards. That's what you want your students to get mastery to learn towards. So what you're doing in that preliminary challenge is you're introducing the authentic hands-on PBL, PJBL learning, and you're seeing where are they currently right now in understanding on that particular unit. So in this one, for instance, I'll give an example. In the preliminary challenge for this, it's an ADA compliant park. So in the ADA compliant park, I'll left click on the 6E lesson plan. And this one is directly around trying to understand how to go through and design an ADA compliant public park. You're asking students to do particular research, and they're going to be evaluated on working within a group overall, as well as presenting their final challenges. So you're really trying to get students to understand, conceptualization, design overall. So you're kind of getting baseline data on where you want them to be towards the end of the unit. Your primary challenge does the understanding of the culminating of learning at the end of a unit. So you're taking the standards, the objectives, the benchmarks, and really what's being assessed in that authentic, PBL, PJBL environment and learning aspect of it, with some formative assessments embedded along the way for the primary challenge. It's a culminating understanding or learning prior to taking that unit test, which is the formal multiple choice. But it gives the educator, I would say, a better understanding of the student's ability overall, understanding what is being taught, as well as where do I take my next steps towards to ensure my students have a complete understanding, even after completing the unit. So you're kind of assessing at the beginning of a unit, at the end of a unit, and that all that in between, all learning cycles in between is kind of like your meats and potato, your tomatoes, lettuce, etc. That's the learning aspect. And then at the end of it, in the beginning of it, are your 2 buns, your preliminary challenge, your primary challenge.
I like the food analogy.
I am hungry, so I'm not going to lie.
Before we wrap up, unless anyone has any further questions, there is a glimpse of TSA crosswalks at the top. So how can you connect TSA to EBD?
All right, for those of you who don't know, overall what TSA is, TSA is a Technology Student Association, in which the national organization for middle school and high school students with an interest in technology and STEM overall. It's an organization, is one of the 9 career and technical CTSOs, and it is the only CTSO with a focus on preparing students for a future in a technologically literate society. That's the buzzword as well too, as a technologically literate society. And as we move towards the STEL, the Standard for Technological and Engineering Literacy, that's a huge focus to make that connection towards literacy overall, as we're preparing students for future diagnostic testing overall, or state tests, or becoming more literate in the I-STEM fields. So the benefits of teaching this coursework and then connecting it to your curriculum. The crosswalks are beneficial for running classrooms because they help to show that direct correlation between what is being taught and then how can it be applied. Quite often, personal experiences, we see sometimes that are just concepts being taught, an idea that's being taught, but sometimes they're missing that application of taking it to the next level. You may, for instance, learn a coding aspect, and then afterwards you go to another coding, or you learn a mathematical equation, and then you fall so far behind because you just don't understand it and they're running the next problem. This kind of focuses on that bigger element as well too. So you may have Pythagorean theorem, then apply it toward the an engineering challenge, for instance, in our crane strain in FOT Unit 2, Learning Cycle 1, or you may go through and learn coding aspect for this when it goes to a robotics portion, and then afterwards you apply it to a rover, and then it traverses over a projected line that you have a program directly to do it towards. So it really takes that, and then it takes that applied learning aspect of it. And then as far as the focus areas in that TSA, which you'll see over here, if I click on the pop out, but what I'll just do is I'll just zoom in right here. If it's 3D animation, if it talks about specifically how much, not all of our coursework, that'd be a lot of different alignments, trust me. Specifically for this coursework, you have your individual numbers and numerical values. These numerical values represent how heavily this is hit on in this course overall. And then it talks about the lessons. So if it's biotech design, it says in this unit with these lessons, it is heavily discussed because it's a 4. If it's a 1, not so much. But if it's a 4, so much. So it kind of says how much they are geared towards in a specific course. And also one thing that I wanted to make notable mention too, as far as being involved in Technology Student Association and being involved in CTSOs, it's a lot of fun for the kids. It adds accreditation for schools at a lot of the times in regards to the overall census for the school. So if you're not currently involved in a CTSO or you're like or a TSA, I highly recommend getting involved in one of those. It's only a larger benefit for your students. And if you want them to be geared towards, current technical student organization and want a content to help to best support that, I highly recommend, reaching out or checking out our content for utilization in your schools.
Awesome. Thank you, Ryan, for those informative answers. I don't believe there are any more questions. So we can go ahead and close up. Thank you again for joining us, everyone. And we have an announcement for